All right, so a cylinder is being stretched. If you want to like imagine a visual of that, a cylinder like a tube that's being stretched. See what I'm saying? So like the radius isn't going to be changing, I don't think, but the like length of it is going to be changing. So R is 5 feet. So it's actually very large. So R is 5 feet. This one is a multiple choice one, so we won't need to worry about the units. It's just going to be printed on the paper. Height is 9 feet. So at the moment that we're pausing, that's what's going on. Oh, the radius is changing. Radius is decreasing. So how will I label this? It'll be negative and it'll be called DR. Perfect. You guys are getting really good at labeling stuff. Negative 0.2 feet per hour. The height is increasing. So dH dt is positive 2 feet per hour. How is the volume changing? I'm not sure if that's going to be positive or negative because the radius is getting smaller and the height is getting bigger. So we'll just have to wait and see what happens. And then we're given the volume formula. What rule do you need for this? Good, because there's an R and there's an H. What is the first thing? Good, pi r squared is the first thing, H is the second thing. So do your product rule. It'll be pi r squared times dH dt plus H times what? What would be your derivative for the pi r squared? 2 pi r dr. Perfect. And once again, on your test, that's the answer. Like that's the derivative because this is a formula and I can't change that. So that's what that's going to be. All right. And then I think we actually have everything as well. dv dt equals pi times, actually, you know what? Let me do the r squared. What is r? R is 5. So that'll be 25 pi because we're going to have to simplify this one the whole way down. Since it's multiple choice, you can't just leave it. So 25 pi times dH dt is 2 plus H is 9. This will be 2 pi. R is 5. So 2 times 5 would be 10. That's 10 pi. And then dr dt is negative 0.2. Since I'm going to have to keep going, I would put that as a fraction. That's negative 2/10, which would be negative 1/5. I would just go ahead and do that because we can't stop here. Like that's not going to be one of the choices. Like your multiple choice will not look like that. All right, so this first part would be 50 pi. And then let's see, 10 times negative 1/5. What is that going to give us? That'll be negative 2 times 9 would be negative 18 and then pi. And so what is that going to be? 32 pi. And then the units, just for the sake of being thorough, would be cubic feet per hour. But again, it's multiple choice, so you won't have to worry about that. All right, 12 and 13 are calculator allowed. I don't think we'll really need it for 12, but they're the two that had the little calculator icon. We're definitely going to need it for 13. All right, a circle is expanding. So like imagine like paint got spilled and that's, you know, or ripples in water, like it's expanding. Radius is increasing 5.5 inches per second. So how will we label that? Yeah, dr dt, and it's positive. How is the area changing? So dA dt is your question mark. It's going to be positive because the circle is expanding. And then you have to pause at a certain moment. So when the radius is 12 inches, you'll notice you weren't given a formula for this one. I only put them on here for the ones that they give you. But you need to know the area of a circle. What is the area formula for a circle? It's pi r squared. You do need to know that. And I think that's fair. That's a little formula, so that's fair. All right, so then your derivative, dA dt equals, and what's your derivative? 2 pi r. I'm going to stop and bring this up because no one this year has brought it in my other class either. So I'm not like scolding anybody, but usually somebody brings it up and nobody has yet this year. So I'm going to bring this up. What is 2 pi r? That's circumference. The rate of change of the area of a circle is circumference. And the reason that makes sense is when you go to change the area of a circle, you just bring out the circumference a little bit. Do you get what I'm saying? It's neat. It's neat, guys. That's cool. This is cool. cool stuff. Get on board. That's neat. Rate of change of area is circumference. The RDT. It's cool, guys. All right. dAdt is what we're looking for. It's going to be 2 pi. What's R? Do we have that? 12. And then dRdt is 5.5. This is going to be a multiple choice one, right? So 5.5 would be 11 halves. We're going to have to simplify it the whole way down. I find fractions easier to deal with than decimals when you have to keep on simplifying, because what's going to cancel here is the 2. Do you see what I'm saying? Like, I don't know, the canceling can't happen when you have a decimal, so I write them as fractions. So what is that going to be? 12 times, well, 12 times 12 is 144, so 132 pi. Ooh, it will be multiple choice, so it won't matter, but for the sake of being thorough, what would be your rate of change for an area in this case? Yeah, square inches per whatever the time was. What was it, second? All right, so a vase has circular cross section. So imagine like a vase that would hold flowers, and the cross sections, like if you sliced it into a million pieces, they're all circular. So each cross section, h inches, so height inches above the vase, has a radius of this. Do you see how it's r in terms of h? It's r of h. That means the further you get off the table, the radius changes. Because you know how a vase would look, I don't know, make fun of my art skills all you want, but like, you know how a vase would look like this? Oh, that's not bad. You see that? Do you see how the radius would change? Like depending on the height off of the table? Okay. Yeah, it's pretty good. There's a picture of that on the test, so it'll be on there for you. Not that you need it, but so R in terms of H, just be careful with that. It's going to be a chain rule. Water is being poured into the vase, so it's filling up. That's a change for volume. When the height is 8 inches, so let's write that down. We're pausing when the height is 8 inches. The height of the water is increasing at 1.2 inches per second. So how will I label that? Height is increasing. dH dt, good. 1.2 inches per second. The height of the water, the vase is not changing shape. It's not an incredible magical vase, the water that's changing. What is, here's your question mark, rate of change of the circumference. So what's my question mark? That's dc dt, cool. I don't actually know if that's going to be positive or negative because their circumference is different depending on what your height is. So we'll have to wait and see. What is the rate of change of the circumference of the water at that time? See where we would go with this here. So I guess we need a formula for circumference. So what is your circumference for a circle? It's 2 pi r. We kind of just talked about that in the last one. So derivative dc dt equals, and then what's that derivative? Yep, 2 pi dr dt. The derivative of 2r would be 2 dr dt. The pi just kind of happens to be there. It's 2 pi dr dt. So dc dt is what we're looking for. So we'll have 2 pi times, now we need to figure out dr dt. So this is where you're like going to have to stop and go back and look at what you have, kind of like a scavenger hunt. Like, here's what I've got. How can I get what I have? We have this formula for r, and I need dr dt. So what am I going to need to do with that? It's going to need to be a derivative. So off to the side here, I'm going to write dr dt. It's going to be r prime of h. But then you have to chain on the derivative of the inside. So you have to chain on the derivative of h, which we were given. What is dH dt? It's 1.2. So let me pull out my calculator. How do I do a derivative on my calculator? Math 8. So just watch. If you guys wanted to watch, you got to watch. All right, so math 8. Now, I know there's R's and H's and C's and all that stuff, but I'm going to type X. Just type X. It's more convenient. And they're not going to give you a nice function. They are going to give you something really nasty. All right. So it's going to be 5 plus 0.7. I'm going to put X plus 3 cosine. Better be in what mode? Radians. 2x to the power 0.1. Close parenthesis. Now at the end, they did actually give you this number as well. We want to do such that what number? 8 inches right there. So I'm going to type all that in, get a number. some of you are typing with me. Did you also get that? It could be that I'm in radians. You got that? Okay, I'll look at yours in just a second. You might be in degree mode. And then I'm going to multiply that. I'm just going to hit times, answer times 1.2, like label that, chain rule. You're going to use that number. It's going to be in there. So I multiplied on the 1.2. So this is math 8. And then you multiply that number on chain rule. So this 8 in this 1.2 is how that gets used. It's math 8. The number just so happened to be 8 as well, but it would be math 8, whatever number that is, times the 1.2. That's what goes right here. So 0.770. Yes. Cool. Okay. I only have the two of you. So I usually look for confirmation. Now, if you type 0.770 times 2 pi, it will not be accurate enough. You have to use this whole decimal, but I have it sitting right there. So I'm just going to do times 2 pi, and then you can truncate your answer. And truncating is what I want you to do. Just take the first 3. If you aren't sure, or like on the AP exam, you're like, I just want to make sure I'm being super accurate, write them all. Like you can write them all, but you need at least the first 3. So 4.840. And it's free response, so we do need units. It was the rate of change of a circumference. That's just a distance around. So that's not squared or cubed or anything. It's not an area or a volume. It's just the distance around. So it would be what per what? Yeah, inches per second.